Today we will be talking about atomic mass. Atomic mass, as the name suggests, is nothing but the mass of a particular atom. Let us consider a hydrogen atom. It has an atomic number of 1 and mass number of 1. Thus, we know that it has 1 proton, no neutrons, and 1 electron in it if it is a neutral atom. Thus, the mass of a hydrogen atom will be the mass of the proton as well as the mass of the electron in it, because atomic mass is nothing but the mass of an atom. Now, we know experimentally that mass of a proton is equal to 1.67 into 10 to the minus 24 grams, while that of a neutron is 1.675 into 10 to the minus 24 grams. Mass of a proton and neutron are almost equal. And mass of an electron is 9.1 into 10 to the power minus 28 grams. Thus, if we plug in the values, mass of a hydrogen atom will be equal to 1.67 into 10 to the minus 24 grams plus 9.1 into 10 to the power minus 28 grams. Okay, so how do we add these two numbers? If I ask you to add 10 to the minus 1 plus 10 to the minus 4, and if you tell me that the answer is 10 to the minus 5, you are absolutely wrong. You cannot add the powers. Let's see. 10 to the minus 1 is 0.1, while 10 to the minus 4 is 0.001. If we add these two numbers, we'll get 0.1001, which is not equal to 10 to the minus 5, because 10 to the minus 5 is equal to 0.00001. So we cannot add the powers. Okay, so what we can do is, I can write the 10 to the minus 28 to be 10 to the minus 4. Minus 4 into 10 to the minus 24 is 10 to the power minus 28. Now 9.1 into 10 to the minus 4 is 0.00091 into 10 to the minus 24. Now if we take 10 to the minus 24 common and add 1.67 and 0.00091, we'll get 1.67091 into 10 to the minus 24 grams. Now as you can see, this is almost equal to the mass of a proton. Mass of a proton being 1.67 into 10 to the power minus of 24 grams. Thus, when we add mass of a proton and mass of an electron, the mass of an electron can be ignored. Why is this so? Just check the values of proton, mass of a proton and mass of an electron. Mass of a proton is of the order of 10 to the power minus 24, while electron is of the order of 10 to the power minus 28. If you divide mass of an electron by mass of a proton, and if you do this, you will see that mass of an electron by mass of a proton comes out to be equal to around 1 by 1800 times. So this means that an electron is around 1800 times lighter than a proton, or a proton is 1800 times heavier than an electron. So if you add proton and electron together, it's definitely going to be equal to mass of a proton, because the mass of an electron is negligible. Okay, let us find the mass of a helium atom. Helium has an atomic number of 2 and mass number of 4. So it has 2 protons, 2 neutrons and 2 electrons present in it. Thus, mass of a helium atom will be 2 into mass of a proton plus 2 into mass of a neutron plus 2 into mass of an electron. So we have plugged in the values of proton, neutron and electron, and if you see, mass of a proton and mass of a neutron are approximately the same thing. So since mass of a proton and mass of a neutron are approximately same, I can add these two values, and write it to be equal to 4 into mass of a proton, and mass of a proton is 1.67 into 10 to the minus 24 grams, plus the mass of an electron. And mass of an electron can be ignored because it's very small. Oops, I missed a 2 here. 2 into mass of an electron. So it does not matter. Mass of an electron is negligible. I have 4 times mass of a proton. So ultimately, mass of a helium atom is 2 into mass of a proton plus 2 into mass of a neutron plus 2 into mass of an electron Mass of a proton and neutron are the same thing, so we can add them together, so it's 4 into mass of a proton, and the mass of an electron can be ignored. Let's take another example. If I ask you to find out the mass of, say, one carbon atom, will you be able to do it? Carbon has an atomic number of 6 and a mass number of 12. So this means it has 6 protons and 6 neutrons and 6 electrons present in it, right? Now, mass of a proton and mass of a neutron are approximately the same thing, so we can write it to be 12 into mass of a proton plus 6 into mass of an electron. Mass of an electron is negligible compared to proton, so ultimately it will be equal to 12 into mass of a proton, which is nothing but 12 into 1.67 into 10 to the minus 24 grams. Let us consider some more examples. Oxygen has an atomic number of 8, mass number of 16. So its mass is 8 into mass of a proton plus 8 into mass of a neutron plus 8 into mass of an electron. Mass of a proton and neutron are the same thing, so ultimately it comes out to be 16 into mass of a proton. And the mass of an electron can be ignored because it is negligible compared to mass of a proton. So mass of an oxygen atom is 16 into 1.67 into 10 to the minus 24 grams. Think about it in this way. We have an oxygen atom with 8 protons, 8 neutrons, and it is surrounded by 8 electrons. What will be its mass? Its mass will be equal to the mass of all its constituent particles, right? So it is 8 into mass of a proton and 8 into mass of a neutron and 8 into mass of an electron. Mass of an electron can be conveniently ignored, and the mass of a proton and neutron are the same thing, right? So it will be 16 into mass of a proton. Thus, if you consider any random element X having atomic number Z and mass number A, its atomic mass will be A into 1.67 into 10 to the minus 24 grams. Say it has Np number of protons, Nn number of neutrons, and Ne number of electrons. Then its mass will be number of protons plus number of neutrons into mass of a proton, right? This number of proton plus number of neutrons is nothing but equal to the mass number. If you do not know what the mass number is, please check out the last video. Sodium 1123 will have an atomic mass of 23 into 1.67 into 10 to the minus of 24 grams. This is because sodium has 11 protons and 12 neutrons in it, and the mass of an electron is ignored. Mass of a proton and mass of a neutron are approximately the same, so we can add them together. So it will come out to be 23 into mass of a proton. Similarly, calcium having a mass number of 40 will have an atomic mass of 14 to 1.67 into 10 to the minus of 24 grams. Thus, it is very clear why we should memorize the mass numbers, because the mass of any atom will be mass number multiplied by 1.67 into 10 to the minus of 24 grams. Thus, this value 1.67 into 10 to the minus 24 grams is going to get repeated over and over again everywhere. So we have termed this as 1U, which is known as the atomic mass unit. Therefore, oxygen having a mass number of 16 will have an atomic mass of 16U. Any random element A having mass number A is going to have an atomic mass of AU. Sodium is going to have an atomic mass of 23U. Calcium is going to have an atomic mass of 40U. So if you have nitrogen, which has an atomic number of 7 and a mass number of 14, its atomic mass is going to be 14U. And in grams, it's going to be simply 14 into 1.67 into 10 to the minus of 24 grams.